Hello, my name is Christian Tinnefeld. I work in a database research group at SAP in Palo Alto. And what I would like to talk about is our work in the context of distributed query processing and our challenges with regards to embedding fabric networking infrastructure. And this presentation is based on the work that I've done together with Markus Dreseler. He's a PhD student working at the University of Potsdam. And I would like to emphasize that the content in this presentation is Markus's and my own opinion. So the University of Potsdam and SAP are both large institutions and organizations with many different groups. So these are basically our own opinions. Okay, so what is the structure of my presentation? First of all, I would like to talk about the motivation. I would like to talk about the research work we do in the group I work in, which is called HANA-VORA. And I would like to talk about the challenge, how to choose a proper communication framework in such a project. So as I said, we are database guys. For you, probably it's a very trivial question, but actually for us, it is quite a challenge. So I would like to highlight that aspect here a bit. Second part is that I would like to talk about making use of multicast and group communication operations in a distributed database management systems. And I would like to highlight which scenarios can benefit, about what kind of payload do we talk. And again, I bring more questions and answers. So what are open questions from our point of view, or what are things that we, couldn't figure out, and now where we try to move ahead and do experiments. And that brings me to the third part. So I would like to talk about RDMA Multicast, benefits of hardware support for doing multicast, experimental setup and insights, and I present the conclusions. So one slide about the project itself. So what we're doing is that we're developing a distributed query processing system. And at the very core is a technique that we use code generation for query execution. So that means in a traditional database system, you will find a set of predefined database operators, such as a scan or join or materialize operator. And what we do is that for each coming query, we generate corresponding C code, which then is being executed, and that brings many advantages. Two of them is that we like to think that we can execute a given SQL query with the fewest CPU instructions as possible, and we can also piggyback on the capabilities of the C++ compiler to optimize code for query optimization. And we are making use of NUMA-aware data structures and algorithms. We provide language binding for all kinds of different languages. And so far, our number one use case for deployment is that we integrate this infrastructure into the Apache Hadoop and Spark ecosystem, because our customers have the desire to, in a unified way, query across the SAP system, the SAP database system, and whatever kind of data is sitting in Hadoop and Spark. So what are our very high-level requirements with regards to the communication framework that we want to use? So from an application developer's point of view, it should be very easy to use, of course, and it should be able to write communication code with as few instructions as possible. Also, underneath, we want to be able to support different available networking hardware, yet we want to make sure that the developer only has to write one line of code in a similar spirit where Excelio and libfabric do it, that you can switch different providers underneath. We want to be aware of NUMA region. We want to also be able to express NUMA region awareness in our networking stack, and we want to have a TCP stack on board that works no matter where. So no matter if it's Windows, Mac, or Linux, or doesn't matter which kind of hardware, it should just work. Not maybe for components who do core processing, but in scenarios where we just want to have a client available that can talk to other components. We want to have an RDMA stack that supports rendezvous and scatter-gather, as well as atomic operations. And ideally, we have group communication operations on board in an MPI kind of style, so they support basic one-to-all, all-to-all barriers, things like that. So now the million-dollar question: what kind of framework should we choose? And there are a lot of things can be said about the positive things about the available frameworks, but I would like to highlight for choices we are considering, some reasons why they don't strike as the one-size-fit-all solution. So of course IB verbs, it's low level and verbose, it's very complex, you have to take care of things you usually take for granted, and it's comparatively low in terms of developer productivity, and it's easy to make mistakes. When it comes to Excelio and something like LibFabric, it's very, very nice that it supports different provider underneath, but then from a very practical point of view, to my knowledge, they don't support all popular operating systems as of now in terms of Windows, Linux, and Mac. So that means we still would need to have some sidecard to be able to have communication going on all of these platforms. And also, not ideal is that, to my knowledge, none of them supports any kind of group communications whatsoever as of now. MPI is very popular for the HPC community, but again, the HPC community has the underlying assumption that the underlying infrastructure is reliable for the execution of an experiment. So yes, there are ways how to do fault tolerance and dynamic scheduling, but it's not what MPI has initially been designed for. And we did a large survey of open source database and data processing projects, including Spark and Impala and Hadoop. And among all of them, there is actually one popular data processing framework called Vector H, which makes use of MPI, but all the other ones do not. So, I mean, that was something that still challenges us in a certain way. At least there's no solution that works out of the box for all the scenarios we would like to have. So what kind of scenarios are there in general that can benefit from group communication operations? Okay, it's a bit small, but I can explain it. So first of all, if you want to transfer data across in your cluster, you might have different data partitions or different data slices, and there are several scenarios that you would like to cover with this kind of operation from a database point of view. On the one hand, you would like to scale out your cluster in a way that you just can make use of more nodes in your cluster. You can provide high availability, that you just replicate your data, or you can avoid hotspots if a lot of queries go against a certain chunk of your data. And here basic one-to-many operations are very important because you simultaneously want to redistribute a certain chunk of data to multiple nodes in parallel. Another big topic is, and there's a lot of work there, especially also in the database community, that you want to make use of it doing query execution and especially distribution of intermediate results during query execution. And here the most prominent operation is the execution of joins. So you want to have, ideally you could make use of one-to-many, many-to-one, or all-to-all operations, and I will talk about that a little bit in more detail on the next slides. Also from the point of transaction processing, one-to-many operations are desirable because you need to make sure that you acquire and release logs across multiple participants in parallel, so that is comparatively straightforward. When it comes to the execution of multicast and in combination with joins, we did some back-of-the-envelope calculations what kind of data volumes or payloads we are going to face. So we identified different join operations and then thought about what kind of group communication operations can be beneficial in this context. And so there are different parameters who can influence these kind of calculations. So depending on the step of the different join algorithm and the number of nodes which are going to participate. And then you can basically assign different group communication operations which would be beneficial for each individual step. And for example, you can then calculate what would be the overall amount of data that is going to be processed with let's say a single multicast operation, or how many nodes are going to participate. And again, for us, the question now is, if we think about different networking frameworks or networking hardware is how well do these operations scale. So for example, how well does a multicast operation scale in the context of RDMA with a varying payload size, with varying number of participants, or when there are different levels of congestions available. And so we talked also to multiple vendors, and so far, we have not found any, precise answer. Maybe the question is imprecise, or maybe we're missing something. But I would just be very happy to learn more about this, or to get a better understanding how we can actually quantify the benefits of modern networking hardware, and how to justify internally and for customers that it makes sense to invest money here. Also in the context of multicast, it's interesting to quantify the costs for creating and modifying multicast groups, and to have like a simple framework to quantify the performance benefits when you compare it just to a series of unicasts. And it's kind of interesting. For example, I'm talking about an open source project here, which makes heavy use of a broadcast join. So you go into the source code and you look at the broadcast join, and it can be executed across dozens of nodes in a deployment, and then you see the broadcast join actually is being executed by a series of unicasts underneath. So again, I would like to understand better, why this is the case, or why, there seems to be a gap in terms of what the capabilities are of modern networking equipment and fabric networking, and what is the use actually, how people who program against it make of it. And at the end of the day, that then brought Markus, again, who is a PhD student, and me to the idea to do some experiments, and I would like to share what we have done so far. Again, this is a work in progress, so it's not complete. So our understanding looks like that. If we have a traditional unicast messaging, the data and the control flow goes from the CPU to the NIC to the switch. It changes a little bit in the context of low latency, where the data flow directly goes from the NIC to the switch and to the different nodes. Again, for multicast, the benefit is that the NIC has to transfer the data only once to the switch, and then the switch autonomously can distribute it to multiple nodes. And that can even be of more advantage depending on the topology. So again, here the difference is that the NIC only has to do the work once, and then the switch is afterwards redistributed autonomously to all the corresponding participants. So how to make use of it? So far, it's only supported by IB verbs, and the API call is RDMA join multicast with the ID, the address, and the context. The different nodes have to join a multicast group, and once the multicast group has been established, everyone may say datagrams to the corresponding multicast group. And based on the measurements we have done so far, one cycle of joining and leaving a multicast group takes approximately 400 microseconds. Now, it depends on your scenario if you consider that as something that is very high or very low. So if in the context of query processing, you can foresee that the groups are stable for quite some time, it's tolerable. Probably it's quite high if you spontaneously for the execution of a single query want to establish and destroy these kind of groups. Before I talk about benchmarks, these have been executed on a very small cluster, which generously has been sponsored by Intel, and we want to thank Kartik Kumar, who's our contact partner, to sponsor the cluster and also to have very fruitful discussions in general. Inside the cluster, we had Mellanox Connect X3 NICs and Switch X2 switch, and we used IB verbs, RDMA CM, and basically our boilerplate here was the MCK key example. And in the different experiments, we varied various factors. So on the one hand, we varied the numbers of receivers from 1 to 7 for the multicast operation. We compared on the one hand a reliable connection done by a unicast and 2 unreliable connection, which first of all was also a series of unicast operations, and then we went for the multicast, and we also varied the number of the payload that has been distributed for the multicast operation between 1 to 240 megabytes. And the main takeaway here is that even with a growing numbers of receivers and even with a growing number of the payload, the multicast approach scales linearly in a very nice manner. I mean, all scale linearly, but the reliable connection approach, so the series of unicasts, as well for reliable and unreliable, performs significantly worse during the execution. Okay, so my conclusions are, if we talk about the communication framework, from our point of view, there's no one-size-fits-all framework available yet. For Excellium and libfabric, again, there's the lack of support for all available operating systems, and again, there's no native support for group communication operations as of now. When it comes to the group communications operations itself, clearly MPI is the top dog, but probably is not the right tool in the context of a distributed query processing system where you require a very high amount of elasticity, and you assume that there's a very high amount of failures going on. And also, if you just browse across popular data processing projects as of now, there's also very little use even of basic broadcast and multicast. And so from our point of view, it's a little bit of a chicken egg problem. So the network vendors make amazing hardware, but the advanced features are hard to use. At least they have not been trickled down to frameworks where the average guy like me can make use of it. And also, when it comes to justifying the investments, at least so far, we are struggling to really quantify the benefits we can squeeze out of it. So again, I probably brought more questions than answers, but I'm very curious, if you're telling me that I'm missing something very obvious, or if all of this, has been solved in a certain way. I'm also very thankful to have the opportunity here to talk to you today. So thank you very much for your attention. And please, do you have questions or answers?
Just a quick detail, when you're creating multicast groups using IB verbs, are you using the connection manager?
Yes.
Okay. Would you consider bypassing the connection manager and querying the subnet manager directly to make those updates if you're looking for improved performance?
You mean updates with regards to the configuration of the multicast group? Or?
Correct, yes.
Yes, but so far we are just in the process of quantifying the benefits of the multicast, of the execution of the multicast operation itself, and then I think our second step is to reason about how to improve performance with regards to group management. Okay. Thank you.